You're watching PowerNation. Today on Carcass, we want the rear of our Camaro to stick to the track. So we'll need to replace the original shock mounts to accommodate our new full float 9-inch rear end.
Plus, we'll mock up our upgraded braking system. Then we'll work on making our chassis more rigid for better handling. Hey everybody, welcome to Carcass. Well, we have our 1972 road course Camaro up on the hoist today, and we're going to be tackling a couple different things. Up front here, we're going to be working on the brakes. We're going to be mocking up a big brake kit because we definitely want to make sure Jimmy and I can handle this thing when it's out on the course. And in the back, since we mini tubbed the car, we're running into a little bit of an issue, but Jimmy has a solution.
And with the mini tubs in it, to get them in there, we had to cut off the stock shock mounts, and now we need a solution to remount them. And the solution is to move them a little bit farther inboard, and I'm going to mount them up on this strong chassis section up here, and this will be plenty strong to handle the shock loads. And that's one interesting thing to note here is that we have a leaf spring and a shock separate, whereas if you had a coilover, you have spring and shock forces going through the same point. And I took some measurements earlier here, so I have some files designed in CAD already for the brackets up on this chassis rail and the brackets on the axle. So I'll head to the plasma table, get them cut out. For the mounts, we'll be using 3/16 pickled and oiled steel, which will be more than enough for the axle and chassis mounts. With the brackets cut out, I'll do a little bit of prep work on the chassis and the axle to get them ready for welding. I've got part of the chassis prep for our shock mount brackets, and here's what we're working with. This top one is kind of a triangular base shape. I've got 2 holes for plug welds, one to just mount the shock, and it's going to land up here. I'm not really sure where front to back yet because I want to get this bracket on the axle first. And as you can see, our shock mount hole is placed quite a ways behind the center line of the axle. So what I'll do here is get this tacked on the axle. I'll hang a plumb bob and make sure I hit dead center of the hole, and then I'll figure out where the center of this bracket should land on the chassis. All right, so as you can see with the center mark on the chassis rail, if I were to line up the center hole of my bracket, it would put it right over this extra layer of sheet metal here, and I don't want to go through all the extra work of peeling that off just to weld a bracket onto this chassis rail. So if I just put it a little bit farther back, it's going to lean back our shock a little bit, but it's still relatively straight up and down, so it's not going to affect the motion ratio much at all. So I'll just get this on here and we'll keep moving forward. We'll just tack these in for now until we can get the axle out from under the car.
Drop that one. Oop, caught that one.
Amateur
hour. It's not heavy, but it ain't light.
All right. With the axle removed, I'll go ahead and fully weld the mounts to the axle. That wraps up the welding on our axle, so now we can get this thing painted and put back in the car. The only thing left for me to do is to weld on our shock brackets on the chassis, then we can take a measurement and order our shocks.
A race car needs to stop fast, so we'll help it out by installing a big brake kit. So guys, like I said earlier, we're gonna be mocking up the brakes on our 72 Camaro, and we got this setup from EBC Brakes. This is their balanced big brake kit with massive 355mm two-piece full floating rotors for the front and their new 6-piston calipers. And in the rear, we're gonna be running their 330mm rotors and their 4-piston calipers. The calipers themselves are machined from a high temperature, low pressure casting, and they're just a whole lot better than your standard gravity fed castings. And the rotor itself is a 2-piece design with a billet aluminum hat and a high carbon, high copper friction ring. So the way that we're going to be setting up the brakes on the front of the Camaro is a little unique in the fact that we actually aren't running a stock spindle for a Camaro. This is a spindle from CPP, and it utilizes a C5 Corvette hub or unit bearing out here. The reason why they do that is the pin on a stock spindle can actually move up and down with force, especially in racing. That force translates into brake pad knockback. What brake pad knockback is when you have that pin move, it can actually push the pads away from the rotor ever so slightly. So the next time you go to step on your brake pad, you have a little bit of delay. Definitely don't want delay in your braking system, especially when you're working on a race car or when you're out on the racetrack. So the solution for that was to run a hub like this. Well, speaking of this hub is set up for a C5 Corvette, which means that this entire big brake kit is actually set up for a C5 Corvette. The way that EBC kind of grafts all of this onto your C5 is they have this billet aluminum adapter that just bolts right over to the hub. And in our case, it bolts up to our spindle that we got from CPP. And then from here, you take your new 6-piston caliper, and that just kind of all bolts right on after you get your rotor in place. This is all just for mock-up at this point. So we've just got some random bolts that we're going to be using to hold all this together. And another thing we did is when we ordered this hub is from SKF. This is their X-Tracker hub. This is 50% stiffer than your stock C5 Corvette hub. And what that helps with is when we run a set of slicks on this car or wide set of tires, it's just gonna further decrease knockback. Again, this all just bolts onto the setup that we have on here now. So we'll go ahead, get the rotor on the car, get the pads and the caliper on, and move on to the passenger side. So a couple more things to add on the brakes here. The color that's on the caliper itself, this is a hard anodized high temperature lacquer coating. This stuff's better than powder coating in the fact that as you put a whole bunch of heat cycles into your brake setup, this stuff won't peel or chip or flake off. And on the rotor itself, again, it's a 2-piece rotor, and what that does is it allows both the hat and the friction disc to expand at different rates. That allows your brakes to run a little more true, and that's a huge plus, especially in the racing world or even in your street driving world. So that pretty much buttons up the driver's side. We'll go ahead, start tackling the passenger side. Now for our brake pads, EBC sent us their Blue Stuff pad that has a medium friction level compound, has fast bed-in times, and a linear performance curve. It's a great fit where lower friction is required to avoid wheel lockup. It's got superb pedal modulation with great fade resistance. Now these pads are exceptionally kind to your rotors. So for you guys that have a performance car that may have expensive 2-piece rotors, this is the perfect fit for that. The pad compound is different than a semi-metallic pad, which may have really good stopping power, but wear your rotors out a lot quicker. We got ours with this stainless steel backing instead of the standard blue backing. They're the perfect fit for our Camaro, or for any of you guys that may have a daily driver that may see some spirited track day use. Now, they're easy to install or replace. On our 6-piston caliper here, all we did was remove the bridge, just slide the pads in, put the bridge back in, slide our bolts in, we'll torque them down, and then when we're ready to hit the track, all we gotta do is pump them up, hammer on the throttle.
All metal surfaces need to be protected from the elements. We'll show you an easy way to keep your project parts looking great.
So with the brakes all buttoned up on the front of the car, we're going to go ahead and make the car a roller again. And since Jimmy has the rear axle all buttoned up, we're going to add some coating to this before we slide it up underneath the Camaro. One thing we do want to do is tape this up before we apply any coating to it. We don't want any paint or any of that stuff inside the pumpkin here or on the snouts on the outside of this. So we'll go ahead and tape this up, we'll hang it up and get ready to spray. Taping everything up now will just save us a lot of time in the long run, especially when it comes time to cleaning everything up and we move on to final assembly. A quick way to take care of the axle ends and the snouts is to use a combination of tape and paper. Now the coating that we're going to be putting on our rear axle housing is called P.O.R. 15. Some of you guys may call it P.O.R. 15. And before we taped it up, I did take it outside and we hit it with their cleaner degreaser, and I also sprayed it down with their metal prep to give it a good solid etch. This stuff can be applied directly over rusted metal if it's prepped correctly, but it is a direct to metal coating, so it works perfectly for bare metal like our rear axle housing is currently. There's a couple different ways you guys can lay this stuff down. You can use a paintbrush or a foam brush. You can mix it up and put it into a spray gun, but you can also just get it in aerosol cans. The way that we're gonna do it is we're gonna mix it up and put it in the spray gun. We're gonna be using the gloss black, so we'll go ahead, get into the mixing room, get this stuff mixed up, and we'll lay down a couple coats. This system is used by automotive restoration professionals, off-road enthusiasts, farming and industrial equipment repair services. Their DTM top coat is a direct-to-metal UV-resistant coating designed to work on prepped bare metal and work incredibly well in applications where there is a need to help preserve substrates susceptible to corrosion. The top coat provides excellent adhesion, UV protection, and is a permanent barrier to corrosion. So we have a really good coating on our axle and it flowed out really nice. And one thing for you guys to note, that if you're not going to use this in a spray gun like we did, if you're going to use it with a paintbrush or a foam brush, you can get pretty much the same results. I've used this a lot in my older street rod building days, and we used to do both. We used to spray it and brush it, and the results pretty much were the same. So we're going to let this set up and cure for a little while, then we'll get it down, get it all assembled back under the Camaro, and we're going to make it a roller one more time.
One really important aspect of any car project is the hardware that you put in it. And luckily for us, our friends at ARP have us covered on our Camaro race car. And some particular areas of interest for us are the brakes, the suspension, and of course, the engine. And two of the most commonly used materials around our shop are the stainless steel and the 8740 Chrome Moly. Stainless steel is great in applications where you need some heat tolerance, resistance to rust and corrosion, and ARP stainless steel has a tensile strength of 170,000 psi. And if we need something a little bit stronger, then we can turn to the 8740 Chrome Moly. This has great fatigue properties, especially in racing applications, and it can be heat treated anywhere from 180 to 210,000 psi. And speaking of our engine, if you guys haven't seen Pat and Frankie build this thing, well, here's what they did. The guys down in EP started with a World Products Motown LS block that has a small block bottom end and accepts LS induction. After honing the cylinders and balancing the rotating assembly, Pat and Frankie got busy dropping in a K1 Technologies 4340 forged crankshaft. Next, the Wiseco forged pistons with Manley connecting rods and Summit Racing piston rings were assembled. Then they were carefully placed into our block. They chose a custom ground cam from Comp Cams to give us a broad torque curve and good track manners. After the internals were complete, a Jezel belt drive was set into place and the Moroso Circle Track dry sump oil pan was torqued down. The machined LME LS7 based heads came next. These have a titanium intake valve with a 2.250 diameter, which allows for 400 CFM of flow, and these heads yield a 13.9 to 1 compression ratio. The accessory drive is from Jones Racing, and it is customized to accept our Moroso 5-stage dry sump oil pump. Up top is an LME billet aluminum intake manifold, and to finish this engine off is a Holley Dominator ECU.
Here we go.
All of these goodies gave this 440 cubic inch engine great numbers on the dyno with an impressive 683 horsepower at 7,500 RPM and a peak torque of 551 pound-feet. We can't wait to get this engine in our car, especially considering how much lighter this thing will be with all the carbon fiber components, but we do have a few more things to do before we can set it in there.
Race cars need to be rigid and quick to respond. We stitch in a few gussets to stiffen up our chassis.
We've been making some great progress on our Camaro road course car, and there's another thing that I want to do to try to increase performance, and that's tying the body into the roll cage. I've already welded the main hoop to the body in the center of the car, so up front here, I'm going to tie in the A-pillar to the side hoop using a gusset. And the biggest reason why we do this is because if we can stiffen up the body and the chassis, we let the suspension actually do its job, and it makes the car more predictable and hopefully lowers your lap time. This gusset I cut out on the plasma table, and I used a dimple die to make these holes. But I'm going to show you guys a way to do this without using any special tools outside of the dimple die, and that all starts with using a manila folder and taking some measurements. All I'm trying to do here is get 4 measurements for the sides of our gusset. I laid a straight line down the roll cage tube to use as a reference. I can also use the A-pillar itself as a reference. And then for the top and the bottom edges, I'm gonna make these parallel to each other. That way I don't have to worry about measuring this angle between the roll cage tube and the A-pillar. So now with my measurements, I can just transfer them to my manila folder, cut it out, and we'll have ourselves a template. I'll start by laying out a center line, the top and bottom lines, and then I'll fill in the sides. Try a little test fit here. And I did make this assuming this piece was symmetrical, which I know it's not, so we'll probably have to make an adjustment. If I line up this edge straight with the roll cage tube, it looks like this lower corner can go in maybe 1/8 of an inch. So I'll just draw a new line, trim it, and we'll retest fit. Now this thing is looking pretty good. It's nice and straight with the roll cage tube. It's mostly straight with the A-pillar. The A-pillar does bow a little bit, so it's not gonna be perfect, but this is good enough now that we can trace it out, trim it on some metal. We're gonna be using 16 gauge steel for the gussets, which is a nice balance between being easy to work with and giving us some strength between the roll cage and the body. Now that I've got my piece cut out, I'm actually going to use the one that I've already made to figure out our hole spacing here, how far off the bottom, and then I'll make a center line and make a mark so we can drill a hole.
3 1/8.
The hole saw size that you'll need depends on your dimple die, so be sure to check with the manufacturer. These gussets often require some massaging to get them in, and having someone to help hold it in place can make it a lot easier. You know, something I really like about these gussets is they give you some performance benefit and they look really cool too.
Yeah, it looks like you got quite a bit of welding to do yet. I'm gonna do a little more cleaning, but that'll wrap it up for us. So until next time, we'll see you guys later.